Hello, welcome everyone to Prime Mathematics. Today we are going to discuss question number 12 from JEE Advanced 2025 Paper 1. Let's read the question. Firstly, we have a function which is defined by f of x plus y as fx into fy. Now, the real numbers a1, a2 up to a50 is an arithmetic progression. And this has been given as well as this also is given. So they are asking to find this. So how to find this? First, we need to check a function that satisfies this condition. Now, the one function that comes into my mind is f of x is equals to a to the power x, where a belongs to R, right? And as such, x belongs to R, right? So, because as we know, f of x plus y, which is equals to a to the power x plus y, and that can be broken as per the exponent rule. So it will be a to the power x dot a to the power y. A to the power x is a function of x, a to the power y is a function of y. So definitely satisfies the condition which has been mentioned over here, right? Now next step. This is the condition of the function that we had to choose to work out this problem. Now since f of a31 is equals to 64 a25, right? So f of a31 is equals to 64 f of a25. Now, by the general term of AP formula, we don't know that an is equals to a plus n minus 1 times of d. So f of a plus 31 can be written as f of a1, where a1 is the first term of this AP, right? So a1 plus 30d, which will be equals to 64 dot f of a1 plus 24d, right? So since our function is a to the power x, in place of x we have this, so it will be a to the power a1 plus 30d, and similarly it will be a to the power a1 plus 24d, right? So now one can break it as per the exponent rule. So it will be a to the power a1 dot a to the power 30d. Then we have 64 dot a to the power a1 dot a to the power 24d. Observe, a to the power a1, a to the power a1 gets cancelled out. So transferring this over to the LHS section, so you get a to the power 30d divided by a to the power 24d. Again using exponent rule, you get a to the power 6d, and that has been equals to 64 in the RHS section, right? So what is 64? Is it something to the power 6? Yeah, it is. It is actually 2 to the power 6, right? Now one can see a to the power 6d as a to the power d whole to the power 6 by exponent rule. So we can observe this 6 power gets cancelled out, so you get a to the power d value as 2, right? This is your first success. Now the second success comes out from the second equation. This has been given. So let's use this. We have summation I equals to 1 to 50 f of ai. Now ai, the general term as per a1 plus n minus 1, but nana, it's not n minus 1 because it's aith term, right? So it will be I minus 1 times of d, right? And that has been already given you the value as 3 multiplied with 2 to the power 25 plus 1, right? So now we can again just substitute as per the functional value. So since the function is a to the power x, so now in the place of x we have this term. So we get a to the power a1 plus I minus 1 times of d, which is equals to 3 dot 2 to the power 25 plus 1 as it is. Now by exponent rule, one again can break this. So summation I equals to 1 to 50. Now it will be a to the power a1 dot a to the power I minus 1 times of d. Now again by exponent rule, one can also write this as a to the power d whole to the power I minus 1, right? And we already know what is a to the power d given. So a to the power d is itself 2, so now we can replace this. We can add as 2, right? And that has been given as 3 dot 2 to the power 25 plus 1. Now, as we know, the series works according to the index I. So a to the power a1 is a constant itself. So one can just simply take it out of the summation. We get summation I equals to 1 to 50. Then we have this as 2 to the power I minus 1, 3 dot 2 to the power 25 plus 1. Now this is the GP. You don't observe? Let's observe. If I put I as 1, we get 2 to the power 0 as 1. If I put I as 2, you get 2 to the power 2 minus 1 is 2. If you put I as equals to 3, we get 3 minus 1 as 2, and so on. And the last term is 2 to the power 49, right? 3 dot 2 to the power 25 plus 1. That is as it is given already. So by the formula of the sum of geometric progression, we know that the formula of Sn is a r to the power n minus 1 upon r minus 1 whenever modulus of r is greater than 1. This is the condition. So here we can see the common ratio is r is 2 and the first term is 1. So first term a, r to the power n. So the number of terms, if you observe, we have 50 terms, right? So it's 2 to the power 50 minus 1 divided by r minus 1, which is given as 3 to the power 25 plus 1, right? Now one can see 2 minus 1 is simply 1, so no need to write. Now 2 to the power 50, one can do a algebraic identity, right? What is the algebraic identity? So 50 is not 55, it is 25 multiplied with 2, right? So it can be written 2 to the power 25 whole square negative 1 square, right? Which is 3 to the power 2 to the power 25 plus 1. Now, as you see, it is a square minus b square, simple algebraic identity of the basics. So 2 to the power 25 plus 1, it is 2 to the power 25 minus 1, which is 3 dot 2 to the power 25 plus 1. Now one can observe on the both other side, 2 to the power 25 plus 1 gets cancelled out. So one can just simply obtain the value of e to the power a1. That is 3 over 2 to the power 25 minus 1. Right? This is the second success. This is our second success. Now our final success is given by this value. So now we need to find the value of summation I equal to 6 to, I think it is 30. Yeah, it's 30. So I do the 6 to 30, f of a of I. Now again, a of I can be generally written as, what can it be written as generally? It can be written as a1 plus I minus 1 times of d. Again, using the function as a to the power x, in place of x, we replace the x. Now we replace the x in the a to the power x function by a to the power a1 plus I minus 1 into d. Now again, one can use this exponent rule. So it can be written as a to the power a1 multiplied with a to the power I minus 1 into d. Now I minus 1 into d can be rewritten as a to the power d whole to the power I minus 1, right? Now, what is a to the power a1? We just find it out. It is 3 to the power 3 over 2 to the power 25 minus 1, right? And what is a to the power d? It is 2. Have you forgotten? No. Since this term is a constant a to the power a1 value, so we can take it out of the summation. So summation will only just get applied for this. So right now we get summation I equal to 6 to 30, 2 to the power I minus 1. So again, you see it is in geometric progression, because when you put 6, you get 2 to the power 5. When you put 7, you get 2 to the power 6. When you so on, put 2 to the power as 30. So it will be 30 minus 1, which is 29, right? So one can just simply again use the formula of the sum of the geometric progression. Now this time, the first term will be this, and common ratio is again 2 to the power 6 divided by 2 to the power 5, which is 2. And number of term this time, if you observe, If you observe, the number of terms can be counted by 30 and 6. 30 minus 6 plus 1, which is, I think, 25. So these number of terms, when you count, it will be 25, right? So 3 over 3 to the power 25 minus 1 dot. What is the formula? A r to the power n minus 1 by the sum formula. And the denominator we have r minus 1. So one can simply observe this can cancel out. 2 minus 1 is negative, sorry, positive 1. And 3 multiplied with 2 to the power 5, which is 32. So after multiplication, you will simply get, I think it is 96. So that's your final answer. That's your final success, right? Thank you, everyone.